Hi, everyone. If you can put your headset on, we're starting now. All right. Thank you. Thank you very much for joining this session. Good afternoon. Hope you had a great day today. We locked you in London Excel on a lovely sunny day. Thank you for being with us. My name is Sandeepan Bhaumik. I am a Principal Analytics Solutions Architect at AWS. Been here for more than 4 years now. And with me, we are honored to have David Sansom from NatWest Group. David will formally introduce himself when he comes up on the stage in some time. We are diving deep into Amazon SageMaker. Well, the next generation of Amazon SageMaker. Before that, let me start with a simple fact. You see, we are struggling with the adoption of AI. And we are struggling not because we lack powerful models. We are struggling because our data teams and our AI teams are working in silos. AI has got all the hype. It has got all the money and funding, and it has got all the talent. But when we look into our organizations, it's often disappointing to see the low adoption rate of AI use cases. Our data teams are focused in building pipelines. Machine learning teams are focused in productionizing machine learning use cases. And business users are focused on delivering business outcomes. But they're moving fast, but they're not working together. And that results in pilot use cases not making to productions, or prototypes not making to production, which is very popular nowadays. AI starts hallucinating, business users lose trust on AI use cases. And all of this happens because there is a massive gap between data and AI. Rarely do we see that teams working in data and AI go and work on a project with a shared ownership or shared outcome. And that's the reason Gartner predicts that by 2026, most of the AI use cases being prototyped today will be dropped just because of lack of good data. So what can we do here? Yes, it is not just a technology problem. It is a human problem. It is a problem with culture, mindset. But most of these problems we can solve with technology. And this is what I'm going to talk about today. How we at AWS are thinking about Amazon SageMaker, the next generation of Amazon SageMaker, to help you close the gap between data and AI use cases. First, let's explore why this gap exists. First of all, very simple. We all know that data accessibility is a problem. Users don't get access to trusted data when they want it. Second, there's a lack of collaboration. We don't really provide collaborative workspaces for our data teams, for our AI teams, for our business users to work together on projects that deliver the same outcome. Then there are different use cases in the data world that demand different technologies. We often tend to push our teams into using one-size-fits-all tools, which hinders innovation. And then there are manual permissioning that we have designed, where a user would ask for access to data and would need to wait for days, if not weeks. And by that time, the use case dies, innovation slows down. And last but not least, the complex ETL pipelines that we spend enormous amount of time in building and locking data into proprietary formats, which are not compatible with open source technologies or any third-party technologies that you would want to use. With that in mind, we want to cover how we are trying to solve these problems with the next generation of Amazon SageMaker. First, I will address what is the next generation of Amazon SageMaker, because that's the most question I get from customers nowadays. Second, we will dive deep into some of the key features. There are many capabilities and features in this service. I want your attention on 5 key features that I will be talking about. And those features are totally targeted in how we are bringing these teams closer, helping different personas to collaborate with different technologies. Then David will join us to share NatWest's story on how they are building their data marketplace using Amazon SageMaker. And then I will give you some resources that you can take away and easily get started when you go back home or go to office tomorrow. Now, what has changed with Amazon SageMaker? Before reInvent 2024, that is December 2024, Amazon SageMaker used to be end-to-end machine learning platform that most of you would know. We rebranded it to SageMaker AI. Everything remains the same. It's just a rebranding to SageMaker AI. And then in the new generation, we have added 3 capabilities. The SageMaker Lakehouse, which brings the data lake and data warehouse experience together at the storage layer. SageMaker Data and AI Governance, where we provide governance capabilities with business-friendly user catalogs, data sharing mechanisms, et cetera, which we will dive deeper into this session. And the SageMaker Unified Studio, a really easy user interface where we are bringing different technologies, whether you're using notebooks for Spark, Python, SQL, any other technology that you would need for AI and data development, we are bringing it together. Now, let's first look at the 5 key features I'll be talking about, and then we will look into demos, and I'll show you some deeper information on how to work with these features. First one is the Open Lakehouse. So we are bringing in the world of data warehouse and data lakes together. We are fronting the cataloging of that experience using Apache Iceberg REST API catalogs. If these things don't make sense to you right now, don't worry, I'll be covering later when we dive deeper. And in that catalog, we are adding business context so that business users, when they go into and look into these catalogs, they can make sense of the data. Second, we are providing this simple user interface that brings data assets, data products, ML models, generative AI assets, all in the same place so that users can collaborate. Third, we are providing a secure, collaborative environment, a workspace that we call projects, where users can go and get access to relevant data for that project, relevant infrastructure for that project, all in a secured environment. Then the automatic permission management. User asks access for data. Data owner approves or denies it, depending on what they decide. And that whole workflow is automated so that they don't have to rely on complex policies that they need to design and apply. And last, multi-engine support from SageMaker Unified Studio. Whether you're writing SQL, whether you're writing Python, Spark, any other generative AI, you're using generative AI models, you can do them from the same interface. Let's start with SageMaker Lakehouse. So the Lakehouse concept brings 2 worlds of data together. The data warehousing world, where you would structure data, store it in a database management system for high performance querying. And the data lake world, where you would store structured, semi-structured, unstructured data for scalability and flexibility, and it doesn't lock you down to the structure. The problem the industry has been facing for the past few years is to achieve a balance between both, customers would end up copying data at both storage layers. That would increase cost. That would increase a lot of operational inefficiencies in managing both worlds. And that's why the Lakehouse concept became famous. Now, as AI adoption rises, we are seeing customers wanting to move to that model more. Because with that, you can have best of both worlds without copying data across. And by opening up the catalog using Apache Iceberg REST catalog, it becomes easier to integrate any kind of tools. How many of you are familiar about Apache Iceberg? Okay. For those who are not, I will get a bit deeper in a follow-up slide and explain you how things work and why we are saying that it's an open platform and how it provides flexibility. For now, just understand this. In AWS, when you're using Amazon SageMaker Lakehouse, at the storage layer, we are supporting Redshift Managed Storage format. The Redshift Managed Storage format is the format when you insert data into Amazon Redshift Data Warehouse that stores the data in a format that we call Redshift Managed Service. And then we have got our Amazon S3 formats where you can store data in Parquet, JSON, CSV, image files, etc. Right? We are also supporting S3 tables, which we announced in reInvent. All of these are natively supported in Amazon SageMaker Lakehouse. On top of that, we have added a catalog supported by Apache Iceberg REST API, where you can make HTTP requests on that catalog to create, update, delete data at the data layer. On top of that, we're using features from AWS Lake Formation or AWS Glue data catalog to provide security management so that you can apply column level, row level, cell level security on top of your lakehouse. Now, the first question is, how do you get data into the lakehouse? What we are doing is introducing zero ETL integration features. So from native AWS database services, you can configure zero ETL integrations, which are nothing but plain replication of data from the database services into your analytical layer, the lakehouse layer. We're also supporting that with our third-party services, third-party applications like SAP, Salesforce, Facebook ads, et cetera, et cetera. Then, where you don't need to move the data or ingest the data, we have introduced zero ETL federated querying mechanism, where you can create federated query connectors to connect to the data and query it from the lakehouse catalog using a querying engine, rather than moving the data into the lakehouse. Now, you can see there are two boxes, a green box and an orange box. When you load data bring data into the lakehouse, if the data natively resides in Amazon S3, RMS, S3 tables, you use a managed catalog using Lakehouse. If you are federating data from third-party databases or applications or using federated query connector, data sets shown on the Lakehouse catalog, we classify them as federated catalog. It's important to differentiate them, and it's important for you to understand the differentiation when you use these services, because some of the permissioning model might differ. For example, when you apply permissions on top of the managed catalog, you can go to column level, row level, even cell level security model. When you're using federated catalogs, we support tag-based access control. With tag-based access control, you can manage data access at scale using data lake tags. So you can tag a user saying EU user. That user would have access to any tables that are tagged with the EU tag. And that way you can scale your tag-based permissions. I think we all are familiar with role-based access control, where you can provide access permission depending on the role of the user. And then we are also supporting zero copy data sharing across these catalogs, not only across AWS accounts, but across AWS organizations. So if you wanted to share data with your customer or partner who have got AWS account in their organization, you can do that using this feature. Now, talking about Iceberg REST API catalog, I wanted to touch this because it's important to understand why we are saying that it is an open data lake now. So Apache Iceberg is a technology that provides database-like features on top of the data lake. You see, data lakes are built on object storages like Amazon S3. They natively don't support what we call ACID transactions in the database world. As in, you cannot make single row updates, deletes, etc. You have to remove the whole object and update with the new object. Technologies like Apache Iceberg builds the transaction log-like technology on top of the data lake so that you can then start doing row-level upserts and deletes on your objects in the data lake. without the REST API catalog, when you implement Iceberg on top of your data lake, the catalog is bound to the underlying catalog of the data lake. So for example, if you had to do it on Amazon S3, Iceberg would be bound to Glue Data Catalog or a Hive Metastore that stores the metadata. With the release of REST API catalogs, Iceberg decoupled this. What they did is they said, now you can make updates, deletes, upserts through HTTP request. Any application that can make REST calls, they can do this. Because you are no more bound to that underlying catalog. You can make REST calls. Now it opens up possibilities with having custom catalogs, having different catalogs in an organization, which we are seeing already happening in different enterprises. And it opens up multi-cloud patterns. And using this on top of Amazon SageMaker Lakehouse, we are opening up our data lake, not only to SageMaker or AWS native services, but any third-party services that can query data or make changes using REST API calls. Now, Amazon SageMaker Unified Studio is the user interface through which you interact, using that you interact with data. I will show you a quick demo because this is a visual service. It doesn't make sense without a demo. This is an out-of-the-console experience. What that means is that the user doesn't need to log into the AWS console to access the Unified Studio. It's supported through SSO, so you can just use your username or you can single sign on into the portal in your organization. Once it opens up, you will see it has got different capabilities that it presents to the user, whether it's working with ML and generative AI assets, working with data assets, or accessing the data catalog. If you look at the top corner, you will see there are 3 menu buttons: Discover, Build, and Govern. This is the way we organize our tools. With Discovery, users can go and discover data assets, right? So solving the problem of searching for data assets and data products. With Build, builders can go and access different tools that they need to work with in the data engineering space, data science, ML engineering space. And with the Govern, we give access to the data governance people who would work at the domain level or domain units level and look into the data that needs to be governed. So that's how we are bringing some of these tools together with Unified Studio. Then comes the business catalog that I was talking about, the SageMaker business catalog. The business catalog adds business metadata to the technical metadata on the catalog, helping business users identify how these things, what the data is about, right? What does that column mean? So if you see over here, a business user, a data publisher would go and select inventory data, for example, and they can use our generative AI description mechanism to generate descriptions for the data asset. So there is an LLM in the background that will go and look into the metadata of the data product and generate those descriptions quickly. It can generate additional README files, glossary terms, and then metadata forms. So right now you can see it has automatically generated the business description. You can now further go and use generative AI to format it as well. You can see in the schema information, you have got not only technical descriptions, but business descriptions. And then you can add glossary terms. So for example, if you wanted to classify a data product as sensitive data, you can do that. And it picks up on the catalog itself. You can also add additional business context using metadata forms. So not only you have the technical metadata information, you can go and add metadata form, for example, let's say ownership. So ownership is a form where you have details of the owner of the data, who should you contact if there is a problem, and you add those details into the data set itself and publish it on the catalog. The value it gives to the business users is when business users go and discover data, which we will see in a follow-up demo later in the session, they can see all of this information and make sense of whether they would need access to this data product to do the job that they want to do. Now, I wanted to quickly show you the big picture on how the project concept works. So if you think about it, in an organization, you would have data producers producing data and data consumers searching for data, looking for data, finding it, and then working on a particular project. Take an example like churn analysis. If you wanted to do churn analysis on your data, you would not only need a data engineer to create the pipeline and bring the relevant data sets to the storage layer, you would also need a machine learning engineer or a data scientist to build the model for churn analytics. And you would also need business users who understand customer churn data and other customer data sets that would make sense to create such a use case. Now, the project concept brings these different personas together into a secured sandbox-like environment where you can secure the data. So you select, when I say you, it's a project admin. So you can have different types of roles in a project. You can have a project admin or a project contributor. The admins can control what data gets assigned to that project by selecting the data sets from the catalog. They can also control what infrastructure is available to that project. What kind of compute does the project need EMR? Does it need Redshift, etc.? They can bring together in a secure environment the decision making of the data infrastructure, the data sets, and the people working in that project comes together so that the people can go and collaborate and deliver this project. This is how data, AI, business teams come together in collaborating with a shared outcome. Admins can create blueprints for projects. So the blueprints are basically CDK or CloudFormation stack that deploys the infrastructure for a particular project. These blueprints are fed into project profiles. So you can have different profiles for a project. A project can be a SQL analytics project, which means that that profile would only have tools related to SQL. You can have generative AI and machine learning profile for a project, which means the relevant technologies will be available in this project. Admins in your organization, someone in IT, can make those decisions, build those blueprints that create those kind of infrastructure, and create those project profiles. Then when you go to a project, create a project, you can select what kind of profile this project would have. And then the automatic subscription workflow. So a user going and, so it shows the experience of how a consumer would go and subscribe to a data asset. So this is a consumer, John. They go and use Amazon Q to search for the data. So in Q, they can search, give me all the relevant data sets to whatever, customer, sales, product, etc. Q will come back with the relevant data sets. I think in this case, they selected inventory. So they will go with the inventory data set. At this time, remember, this is just the metadata that they're looking at the catalog. They don't have access to data yet. They're looking at the different descriptions, and then they say, okay, yeah, this will work in our project. We'll ask for access. They request access. And once they request access, that access request goes to the data owner, a data steward in a producer, another team, right? The data owner logs in, they find this request, they check, okay, this user asked access for this data set. They can actually apply column level filters or row level filters at this time. They can also give full access to this user. Depending on what they want to do, they will select an option, let's say full access, and then they will approve this request. Once and only once this request is approved here, the subscriber who made the subscription request would have access to that data. This solves a lot of pain around provisioning complex IAM policies on top of your data, which not a lot of business users or data stewards would know. They would have to rely on IT or admin to do it for them. This democratizes that experience and brings down the time to access for data products. Now, I would request David to come up on the stage and share NetWest's story on how they are building the data marketplace with SageMaker.
Thank you, Sandy. Hello, everyone. Good to see so many friendly faces in the audience. I'm David Sansom. I work at NatWest and I lead our data technology, basically providing shared data platforms and AI tools to various teams across the bank. So NatWest is a UK-focused bank serving over 19 million customers. We process 1 in 4 of all UK financial transactions, so it gives us a huge scale advantage when it comes to data. Our aim is to help our customers progress to reach their goals. So, that might be buying a house or starting up a business. And using data and insight, we can help anticipate, understand, and respond to customers' changing needs faster and more efficiently. The availability and accessibility of current, complete, detailed, accurate data, together with the appropriate governance and accountability for that data, is fast becoming a critical strategic asset. If you saw our CIO during the keynote this morning, you'll have heard him talk about us seeing AI as the fifth technology revolution, following the invention of PCs, the internet, smartphones, and cloud. AI enables a comprehensive reimagining of operations, product development, risk management, and allowing us to deliver personalized services and novel solutions while also streamlining mundane tasks. So I'm going to talk about 6 data challenges we were facing, and then on the next few slides, I'll talk about how we solved for them. First one is finding trusted data. So data science teams need data from across the bank, but there was no central data catalog, which made it really hard to find data across disparate platforms, which were owned by different parts of NatWest, each with their own processes to request access to that data. IT changes were often required to provide access. Even if the data was on AWS, it might be in a different AWS account owned by a different team. And it could take a month to request access. It might even need an IT change to do some infrastructure as code change in order to grant that access across the accounts. Also, fragmented tools. So multiple query tools might be needed to access data. Might be some data in Oracle, in SQL Server, in Snowflake. And even if all the data was in our AWS data lake, AI projects often needed to request environments. They might need to request some compute, some storage, some scheduling tools, some Bedrock AI tools. And requesting those environments and setting them up and provisioning them could slow down the time to value. And collaborating across the bank could be hard. So we might want to work on a pricing optimization project. It might need someone from risk who understands the default rates on loans. It might need someone from finance who understands the interest income. The data science team would want to collaborate with them. And that's not easy to do if they all are used to using different tools. And then our data lake versus our warehouse. They became almost data silos. We were often moving data from the data lake into the data warehouse, which increased costs, led to multiple copies of the data, and that data could go stale. Multiple security models also had to be maintained. And not all tools could connect to both the lake and the warehouse, because maybe we hadn't wired them up. And that would create more friction. And then enterprise reuse. Building once and using many seems obvious, but agreeing on a bank-wide data transformation strategy and aligning our various change programs across the bank to contribute to that strategy required winning a lot of hearts and minds. And then legacy platforms. So we'd brought in modern cloud data platforms, but some users and some jobs were still running on the legacy platforms, leading to us paying for both the old and the new, and also having to spend valuable time remediating end-of-life issues. Last year, we decided to adopt a data mesh architecture and for domains to publish their data products. We'd already split our applications up into domains around the bank. So one of our 50 domains is called Home Buying and Ownership. And that domain are the experts on their mortgage data and well placed to own that data, publish, maintain, look after the data quality of that data product. AWS have been a great partner for us, and so it was a natural choice to select AWS Data Zone for our data marketplace, providing a data portal, a business data catalog, and governed data sharing. Data Zone makes it easier to find the right data, connecting the data producers and the consumers, and unlocking data across organizational boundaries. Not only can you search for data, but you can then click to get access, and that's self-service in minutes rather than weeks. It's almost like a workflow for data mesh. And there's consistent and unified fine-grained access controls to secure and share data. And the data quality and data lineage are also integrated into that data catalog. Indeed, actually, the data quality is integrated into the data lineage, and that helps build trust in the data. So Data Zone helps solve two of our data challenges. This year, we've been working on data tooling simplification. We were already using Amazon SageMaker for AI, but now we're rolling out Unified Studio to data analysts and data engineers, as well as the data scientists. All tools in one interface for all of those personas. We're also upgrading Data Zone to SageMaker Catalog. I almost see that as sort of version 2 of Data Zone. Still using Data Zone under the covers, but there are some upgrades to be done there. And we're really excited about the Unified Studio Creator Project functionality that Sandy was explaining. That self-service creation of environments that enables faster collaboration across the bank, faster time to value, environments provisioned in minutes, whereas previously it could easily take 2 months. And it has Q developer code suggestions built in. And actually today, we have just gone live with SageMaker Unified Studio. This year, we've also been working on SageMaker Lakehouse adoption. This addresses the data silos and the duplication issues I spoke about. And basically, the data is all accessible via a unified interface. No need to move the data between the lake and the warehouse. You can query that data in place. On the simple diagram on screen, I've got our S3 data lake and Snowflake, but we're also working on connections to on-premise Oracle databases and zero ETL integrations. So, our data marketplace foundations are in place. We have now mobilized a data transformation initiative to realize the potential of AI and reinvent business processes. We are setting up data product factories to accelerate the production of data products and drive consumption across our franchises and functions. We're also accelerating migration and decommissioning of our legacy data platforms to simplify the IT estate and improve agility and reduce costs. Again, our CIO on the keynote was talking about when it's hard to predict the future, we're in uncertain times. The thing that we think we can do to be prepared is to make sure we've got the agility to adapt, and we feel that simplifying our data architecture helps with that agility. The goal is to empower the entire business to become data consumers and drive the federated creation and use of analytical solutions, leveraging GenAI talk-to-data style capabilities. So to conclude, I just wanted to share some of our GenAI successes. We are already seeing great returns and great outcomes from AI in the bank. In terms of colleague experience, this month we launched our biggest GenAI experiment yet for colleagues, and we've rolled out GenAI Copilot tools to 60,000 employees in NatWest to boost productivity and free up time to spend on positive customer outcomes. Our internal version of the chat assistant provides a secure environment to help colleagues get into the habit of using GenAI and learn about prompt engineering. NatWest employs about 10,000 software engineers, and we're rolling out GitLab Duo to support our experts with code suggestions, test creation, and documentation to accelerate safe software delivery. We're also reinventing processes. So GenAI is being used to reduce our complaints handling response time by assimilating relevant data and drafting a customer response, drafting a letter for the customer. We still have humans in the loop reviewing that output, but it's still saving us about 20 minutes per case. We're also using summarization tools for relationship managers. So when they're meeting with customers, it helps them focus on the customer conversation rather than note-taking. And again, saves about 15 minutes of time by capturing the actions. For fraud, we used graph embeddings to enhance fraud detection on inbound transactions and speed up exiting money mules. And it sped that up on an average of 18 days. And then for customer interactions, so Cora is our 24/7 digital assistant. It handled 11.2 million customer conversations last year. We ran a Cora Plus, we called it, GenAI pilot, and that demonstrated higher levels of customer satisfaction and a reduction in colleague handoffs. So not only were customers getting the right support faster, but colleague time is freed up, allowing them to then spend time with customers and providing that personal, empathetic support when it really matters. And finally, personalization. So we've used GenAI to create hyper-personalized, brand-compliant content that can be delivered at scale. And for one of those campaigns, it delivered a 900% increase in savings account applications. Thank you. I will hand back to Sandy, who's got some more demos for you.
Thank you, David. Okay, so I have got two more demos. I'll start with the data processing and analytics part of the SageMaker Unified Studio. Something that you might have noticed by now is SageMaker, the next generation of SageMaker, is not a new service. We are combining our existing services, whether it's EMR, Glue, Data Zone, right? All of the capabilities of the services that we have built, we are breaking that in the SageMaker experience. The same happens with the data processing and analytics experience within SageMaker. You can use EMR compute, Glue compute. You can use managed Airflow for Apache Airflow for orchestration, Athena, Redshift, etc. Right? We provide these different technologies for processing and analytics through Unified Studio. For the sake of time, I cannot show you all of these demos, but I have included the SQL analytics demo to show you the experience of how a SQL user would interact with the system when they go into the Unified Studio. So this is a SQL user. They would go to the build and the query editor, where they get on the left-hand side access to the catalog. So SageMaker catalog, where they can see the data tables within the catalog, This is a SQL analyst trying to do some churn analytics queries using the SQL notebook that we have got on the query editor. They run a query, get some data. The purpose of this user is to do some analysis on the data and create a new table with some combined data from different tables for other users to use. We also provide assistance through Amazon Q, so you can write English language to generate SQL queries on top of these editors. Once the user is satisfied with the query, they can bring it down, drag it down to the notebook. That gets saved in the notebook, and then they can start querying or adding it to as a script as well. You can connect to different database systems and different engines from here, and the different types of catalogs that we discussed. You can use federated query connectors, so connecting to different Oracle database, DynamoDB, RDS, etc. Over here, you can see in this query, the SQL user has combined some tables and looking at the result. Once he or she is satisfied with that, they will create the table for others to use. So you see, they're creating this table as customer combined data. As they create the table becomes immediately available on the catalog. That means someone working in the same project can immediately look into the data and do further analytics downstream. Now, we have had, in the data processing view, we have similar experiences for data engineers working with Spark, with Jupyter Notebooks. I'll show you a machine learning engineer demo, which will show that example. SageMaker AI, as I mentioned, it remains same, but with enhanced capabilities, right? So we are adding generative AI capabilities. With SageMaker Jumpstart, you can do a lot of stuff in building your generative AI applications. The value now you get is that from within SageMaker experience, you can get access to the data on the catalog, wherever it stays. You can have secured permissions. You can work in projects and collaborate together. So all of these values are the new features make available in SageMaker. Let's look at a machine learning engineer experience. So a machine learning engineer logs into the Unified Studio, and they look at the project. They can go into the churn analytics project, look into the query book, notebook. Again, a data engineer would have similar experience because they work with Jupyter Notebooks mostly. But you can see we integrate it with GitLab or GitHub. So you can see the version control, all the files that are created during these projects are version control to Git. This is a pre-configured notebook. You don't have to focus on the code. What this engineer is trying to do is create a churn analytics prediction model. And they use SageMaker Autopilot to create this model, right, and train this model. So once they go, they're satisfied with the data. One of the things that I like is Amazon Q here. I personally, when I use it for documentation. You can go on the cell of the code and say, explain this code. It generates nice documentation that you can embed in the same notebook, but it also helps you optimize your code, troubleshoot, right? So it becomes a lot easier for engineers and machine learning engineers to try this stuff in the notebook experience. So now the machine learning engineer can go and look at the jobs that are trained, look at the inference endpoint that was created. So right from looking into the notebook, training the models, creating the models, generating the inference endpoint, they do end-to-end in a managed environment. Same with generative AI assets. You can go and explore the generative AI playground in SageMaker Unified Studio. You can go and select the generative AI model that you want to use. By the way, the admin can control which models are available to the users in the SageMaker experience. When they set up SageMaker in your organization, you can select the models that the users would have access to. Once you do that, you create some of these assets. So this is a demo of a text-to-image generation model. So you can go and select the right model, the right kind of compute that you would need. and then generate the text using the notebook. So you look into the inference endpoint that got generated, and then you will open the text generated by the LLM into a notebook, and then you will just basically run a prompt. In this demo, the user runs a prompt to create an image. The demo has a very bad prompt, by the way. Don't write prompts this way. It's just a 2-word prompt. But what it does, it basically generates an image from the assets and the churn prediction model that the engineer created. At the end of the day, what you are doing is a SQL analyst creates a combined table from customer churn data. Machine learning engineer picks data from that table into a Jupyter notebook, uses autopilot to create a churn prediction model. A generative AI asset, a generative AI user, it could be a marketing user, could be any business user, goes to a generative AI playground, uses the data from the inference endpoint, uses generates some text out of it, and then creates an image, which is a not very good image, by the way. That's why you should write good prompts, but generates this image for marketing purposes, right? End-to-end experience. So I want you to take away this from this session. As we work with data and AI, every permission we give, every data set we create, every data product we publish, we are building bricks to close the gap between data and AI adoption. And with Amazon SageMaker, we are trying to do this, and we are on a mission to do this for customers like you. 3 really good resources I'd recommend you take a note. First of all, the product page gives a lot of information around the project, the positioning. Second one is an interactive demo. You can go and play with SageMaker on a web browser. So it's not in your AWS account. It's basically a web browser. It's like a tour guide, right? So you just go and click and see how to create different things in SageMaker. The third one is a workshop. It can run in your AWS account. We also run immersion days. If you know that we run workshops with customers, so if you are interested, you can join with us to run them where we provision accounts for you. There are lots of trainings, free trainings available on AWS. You can go and learn on AWS Skill Builder. And one last thing, please provide us some feedback on this session. It's really important for us to look into the feedback so that we can optimize these sessions for future. A big round of applause for David Place, who has joined us from NetWest to share their story. And thank you very much for joining us. I'm pretty sure the drinks are open by now, so you can go and have a great time now. Thank you very much.